Hello friends, myself Rajendra Mahajan presenting my video on Laplace Transform. First example, find Laplace of sin 80 and Laplace of cos of 80 using property of linearity. If Laplace of f of t is f bar of s and g of Laplace of g of t as g bar of s, then Laplace transform of capital A into f of t plus capital B into g of t, where capital A and capital B are constant term, is equal to A into Laplace of f of t. We take constant term outside the operator of Laplace plus B into Laplace transform of g of t this property is called as the property of linearity, and we use this property to find the Laplace of sin 80 and Laplace of cos 80. We know that sin 80 we can write as e raised to iat minus e raised to minus iat and whole divided by 2i. Taking Laplace on both sides, therefore Laplace transform of sin 80 is equals to 1 by 2i constant term outside, Laplace transform of e raised to iat minus e raised to minus iat. It is equals to 1 by 2i as it is. Laplace of first term, it is 1 upon s minus ia, and minus Laplace of second term is 1 upon s plus ia. It is equals to 1 by 2i as it is, no change. Cross multiplying it, we get s plus ia minus s minus ia and whole divided by a product of a plus b into a minus b. That product is a square, means here it is a square minus b square I a whole square 1 by 2i s get cancelled, ia plus ia we get 2ia whole divided by a square. Value of I square is minus 1. That minus and this minus, it becomes plus a square. And therefore, Laplace of sin 80 as a upon a square plus a square is the required answer. Similarly, we can rewrite that cos 80 as, in terms of exponential form, e raised to iat plus e raised to minus iat divided by 2. Taking Laplace on both sides, Laplace of cos 80 1 by 2 constant term outside, Laplace of remaining term e raised to iat plus e raised to minus iat. It is 1 by 2 into Laplace of first term is 1 upon s minus ia plus 1 upon Laplace of second term is 1 upon s plus ia. A cross multiplication, 1 into s plus ia, we get s plus ia, and plus 1 into s minus ia is s minus ia, whole divided by, once again, the product of a plus b into a minus b as a square minus b square. For that product is a square minus ia whole square. Simplifying it, we get 1 by 2. S plus s, we get 2s. S square, I square is minus 1, minus minus plus, we get a square. 2 to get cancelled, and therefore we get Laplace of cos at as s divided by s square plus a square as a required answer. In both, I have applied a property of linearity to obtain this result. Find Laplace transform of t raised to n into e raised to at. To obtain this Laplace transform, we can perform it by two ways. If we consider f of t as t raised to n, and as it is multiplied by e raised to at term, it is a problem of first shifting theorem. Or if we consider f of t as e raised to at and then it is multiplied by t raised to n, we can use that property of multiplication by t raised to n. But here I am solving it by a first shifting theorem. We know that Laplace transform of t raised to n, there are two values, gamma n plus 1 divided by s raised to n plus 1, or second value is n factorial divided by s raised to n plus 1 if n is positive integer. Okay, and therefore by first shifting theorem, before that we call this as f bar of s, say two values, either first one or second one. Laplace transform of t raised to n into e raised to at, as it is multiplied by e raised to at, replace s by s minus a in the previous result, and therefore we have gamma n plus 1 divided by, this s is replaced by s minus a, and therefore s minus a raised to n plus 1, or we have another result, it is n factorial divided by, again s replaced by s minus a and raised to n plus 1 as the required answer, or the required Laplace transform of t raised to n into e raised to at. Important one is here application of that first shifting theorem. Last example, find inverse Laplace of log of 1 minus a square by a square. Therefore, to obtain this, let's consider that given f bar of s as log of 1 minus a square by a square, nothing but log of, cross multiplying it, we get s square minus a square divided by s square. Applying laws of logarithm, log a by b is log a, means s square minus a square, and minus log b means log of s square. And as it is function of s, differentiating it with respect to x, differentiating with respect to s, we get f dash of s as 1 upon, derivative of log is 1 upon s square minus a square. Chain rule, derivative of s square is 2s minus derivative of log s square is 1 upon s square, and again chain rule, derivative of s square is 2s. Simplifying it, we get 2s divided by s square minus a square minus 2 by s. S upon s square minus a square, first term, and minus 1 by s, and that is equals to f dash of s. Next step is taking inverse on both sides. Inverse Laplace of left hand side, inverse Laplace of right hand side term. And to obtain this, we use one theorem, inverse Laplace of f dash of s as minus t into f of t. And therefore, inverse of left hand side is minus t multiplied by f of t, and that is equals to 2 constant outside. Inverse of first term, s upon s square minus a square. Standard result, it is cos of at minus inverse of second term, 1 by s is 1. Dividing by minus t, we get, therefore f of t is equals to 2 times cos at minus 1 divided by minus t. And therefore, we have f of t is equals to, multiplying by minus inside the bracket, we get final result as 1 minus cos at and divided by t as the final answer of the required Laplace transform. Inverse Laplace transform. Therefore, in this video, I have discussed 3 simple problems on Laplace as well as inverse Laplace transform. Please like my video, share it, as well as subscribe to my channel, and to receive the notification of all my new videos, please press the bell icon. Thank you. Thanks for watching.